Today we're going to look at our last lesson in Unit 1, our mid-segment of a triangle lesson. So if we look at our opening exercise, the length of XY is 18 inches. Point K is on the segment XY such that K bisects segment XY. As we start to get better at our vocabulary, hopefully we're going to start to remember that bisects is really just fancy for cuts in half. So if we're looking at the fact that we have our segment XY, and in total that segment is 18 inches long, if we put a point K that cuts it in half, hopefully that's standing out to us that the length of XK would be 9. Same thing as YK. So we're going to fill in the blank here for another vocabulary word. The point K is the blank of segment XY. And hopefully just based on our picture, we can figure out that we can see K is the midpoint of segment XY. Okay, so bisects and midpoint, just some carryover vocabulary from earlier on in the year. Here's the actual definition of a midsegment. It's a segment connecting the midpoints of two sides in a triangle. And you can see I have a lot of stuff labeled here in our diagram. So if I were you, I would take a second to pause this video so you could copy down the rest of the diagram, and then I will go over it. So you can see I have a lot of stuff here. So the mid-segment is this red line right there. That is our mid-segment. And you can see it does a whole bunch of things. And we'll really talk about the properties a little bit more in a couple minutes. But it splits the left side in half, hence the 1/ mark on the top and the bottom. It splits the right side in half, the 2/ marks on the top and on the bottom. Now, the left side and the right side are not necessarily related to each other, but it does cut both of those sides in half. The other thing it does is it's parallel to the side it doesn't intersect. So those are our arrows on that middle side and bottom side. What I've done is I've put in our congruent angles with our hooks. Those are our corresponding angles on the left-hand side and on the right-hand side. And you'll also see the X and the 2X. And that's because one of our rules for midsegment is that the midsegment is half the length of the side it does not intersect. Or the length it does not intersect is double the length of the midsegment. And these are all rules we're going to establish on the next page, but this is what they look like in a diagram. Now I'm going to have you pause the video in a second to actually do this construction, but I have it done already for simplicity purposes. What we need to do is we need to find the midpoint of our two sides. So if we want the segment parallel to BC, we have to find the midpoint of AB and AC. And if we remember, the way we do that is we do that through our perpendicular bisector construction. So if we do the perpendicular bisector construction, you don't actually have to draw the perpendicular bisector line. You just have to lay your ruler down to get your midpoint. And then once you get your midpoint, then you can connect both of them, and there's your midsegment. So pause this video for a second to do the actual construction. So again, here are our properties. The midsegment is half the length of its parallel base. So that was the X and 2X part of our diagram from above. So if we take a look what I have in dark blue here with the X and the 2X, that is our first property. The midsegment intersects the two other sides of the triangles at their midpoints. So if we go back to our original diagram, that is our 1/ on the top and bottom of the left, and our 2/ on the top and bottom of the right. And our third piece is the midsegment is parallel to the base. And you can see in parentheses it has corresponding angles. Those are my hooks. Those are my 1 hook on each of the left-hand side and 2 hooks on each of the right-hand sides. So when we talk about our carryover parallel line properties, corresponding is going to be the one that is most important to us here. So in exercise 2, apply what we know about the properties of midsegments to solve the problem. We want to find X. Well, X is on our midsegment. Our midsegment is half the side it is parallel to. So since it's parallel to the 30, half of 30 is 15. So our midsegment is 15. If we want to find the perimeter of triangle ABC, we have to match up our slash marks. So if A to the midsegment is 9, that means from the midsegment to B is also 9. Remember, our slash marks means they're the same. Same thing on the right-hand side. I'm going to put in my 10 and my 10. So that gives me a whole of 18 on the left, a whole of 20 on the right. So if I want to find my perimeter, I'm 18 plus 20 plus 30, and that gives me a perimeter of 68 for my triangle. Now I'm going to start to find some angles here. So if I look at angle X, right down here with the 50, those are corresponding angles, which means they are equal. So right away, I can get that X is 50 degrees. For my Y, you can do a bunch of different things, but the easiest realm here is to look at the big triangle, EDF. We have a 50, we have a Y, and we have a 60. So we don't have to use any fancy properties for this one. We can just use our regular triangles add up to 180 rule. Now, is this the only way to go about it? No. You could use other rules, other properties that will help you. But in my opinion, looking at the big triangle alone is our best way to do it. So we end up with Y being a 70-degree angle. If we look at number 3, we want to find X. So the way I'm looking at this is, I know AC is parallel to HI. So basically we have 3 midsegments. So rather than just drawing the one midsegment, they drew in all 3 of them. So what that tells me is I've got my corresponding set of 40-degree angles at C and at HIB. For the same purpose, my right-hand side is parallel to GI. So by the same rules, I have my 61-degree angle that's corresponding at angle B and then angle GIC. And now all 3 of those angles are supplementary. So 40 and 61 is 101, and 180 minus 101 gives me 79 degrees. So angle X is 79 degrees. Okay. Again, not the only way you can do it, but based on what we know so far, probably the easiest way to do it. So I'd like you to pause the video and try exercise 3 on your own before you start the video again to check your work. In the diagram below, the vertices DEF are the midpoints of the sides of the equilateral triangle ABC. So what they've told us is DE, EF, and DF are all midsegments. And the perimeter of triangle ABC is 36. What is the length of EF? Well, they gave us a couple of important pieces here. They told us the perimeter of the whole triangle, but they also told us that it's an equilateral triangle. So if our entire perimeter is 36, that means each of our sides has to be 12. 36 divided by 3 is 12. So now the way I'm looking at it is EF parallel to AB, so X is going to be half of that 12, which is going to be 6. Right? So that midsegment EF is just going to be half of its parallel base, AB, so half of 12 is 6. What I would like you to do is the same thing. I'd like you to pause the video and try exercises 4 and 5 before you restart the video to go over how to do them. In the isosceles triangle RST shown below, RS is the same as RT, or is equal to, right? The squiggle over just means congruent, but for our purposes, we are looking at equal. M and N are midpoints of RS and RT respectively, and MN is drawn. That tells us that MN is our midsegment. If MN is 3.5, and the perimeter of RST is 25, determine and state the length of NT. So lots of work to do here. So the first thing, really the first and only thing I can do right now is, if my midsegment is 3.5, that tells me ST is 7, because ST is double MN, Okay, that side, that base side that's parallel to our midsegment is double it. So the next thing is, if I know my perimeter is 25, and I subtract out the 7 used on the bottom already, I have 18 left for my two other sides of my triangle. Now the key is that they told us it's isosceles. So that means both of those sides are exactly the same. So our S is 9 and RT is 9. We also know that because MN is a midsegment, RN and NT are exactly the same. So NT is really just half of 9, which is 4.5. So we got to use a couple of midsegment properties here along with our isosceles triangle to be able to get that one done. And the last one is in the diagram below of triangle ABC. DE and DF are midsegments. If DE is 9 and BC is 17, determine and state the perimeter of quadrilateral FDEC. So we have one of those sides so far. So now let's take a look. If DE is a midsegment parallel to the bottom, that tells me the whole bottom is 18 because it's double whatever our midsegment is. Now, because DF is also a midsegment, I know that F is a midpoint, which means I've got 9 and 9. Okay. Also, because I know it's a midsegment, I have BE at 8.5 and EC at 8.5 because half of 17 is 8.5. Well, DF being a midsegment and parallel to BC, it's half of 17 as well, which is 8.5. So I have a couple of 8.5s and I have a couple of 9s that are making up my perimeter. So if I add up the 8.5, the 8.5, the 9, and the 9, I get a perimeter of 35 for my quadrilateral. So that's a brief introduction to midsegment. We are going to look at it again in one of our later units, but this is how the midsegment of a triangle works and some of the properties associated with it.